Hey guys, what's up? Welcome to the stream. This is my second stream, and I'm actually going to be starting out doing the exact same thing as I did on my first stream. So, I've got some boxes here, and we're going to be soldering some circuit boards today. So I've got some circuit boards in here, and then the bottom box here is all components. Lots and lots of components. So I guess we'll basically just get right into it. What these boards are for are to control a snow machine in a Christmas light show, like an animated Christmas light show, and they basically let you control the snow machine with a computer. So I have two different boards that I need to make. I have one that's just a little board like this, and it's just a relay module basically. And so these snow machines they're not real snow machines. They don't make real snow. What they put out is actually little clumps of bubbles that look like snow, and they use like a bubble solution to do that. So this little board here is for automatically refilling that bubble solution, because there's like a small tank in the snow machine itself, and then you put like a 5-gallon bucket of solution like down on the ground next to it. So that way you don't have to, constantly climb up a ladder and, to the top of your house and refill a snow machine. Because they go through solution fairly quickly. So we're going to be making one of these, and then I'm also going to be making one of these boards here. So I'll put those over there. And that's the actual controller for it that allows you to control the snow machine with what's called a DMX network, which is basically just like a protocol used for controlling stage lighting and that kind of thing. And it's fairly commonly used in the Christmas lighting industry for controlling, Christmas lights and other types of lights and snow machines and that kind of thing. So, why don't we start with the bigger board, since this is the main controller. I've got some BOMs here. BOM stands for Board of Materials, or Bill of Materials, sorry. And it basically just has a list of every single part, every single component that goes on the circuit board, and what type of component it is, the part number, all of that. And then the designator here, it's like C1 and C2, and then that's what's actually labeled on here. Like you can see right there is C1. Well, you could see that if I zoomed in and focused a little bit. It says right here, this is C1, and C2 right there, and then you know exactly where to put it. So my soldering iron's already nice and warm. Let me grab my little silicone soldering mat thing to protect my table and get all this stuff out of the way. And I have this nice little circuit board holder thing here that's really nice for soldering, because you can just put a board in here, something like that, and then you can spin it around and easily access both sides of the board. So, yeah. Hold on, there's like a giant reflection on this board. Let me turn some lights off quick. There we go, that's better. So, let's just jump right into this. Whenever I'm soldering a circuit board together, I want to start with the smallest and shortest components. So that way they're easy to hold in and you don't have a bunch of big stuff in your way. And then you go up in size to bigger stuff. So resistors are always a good place to start, which I have some resistors right here. All of these here are resistors. So let's start with those. So in my wonderful box of goodies here, which used to have a 3D printer filament in it. I now have a bunch of other stuff in here. There's some resistors. Let me just look through here and pull out all the resistors. And some of these are for this board and some of them are for the other board. That might be all the resistors. Here's some diodes. I'll get those out a while. Okay, I think that's it. So, we'll just start at the top here, and R1 is a 1 kilo ohm resistor. I think these ones are for the other board. Right here, 1 kilo ohm resistor. And we need just one of those. Yes, just R1. And let me see if I can find, I have this little 3D printed thing that helps bend resistor leads. To like bend them into the right shape. Let me see if I can find that real quick. I have no clue where I put that. Here, I got it. So, I'm not sure what size these are. Probably the second size here. We'll try that. And basically all you do is stick this in like this. And then bend them down. That gets you like nice, perfectly bent and sized resistors. Yep, that's perfect. And then what I like to do is just flip it over here and just bend these leads out like that. So that way it stays in place. So we'll put in all the resistors first, and then I'll solder them all together. And we need two 220 ohm resistors. Those are R7 and R8. Okay, and we need a 10 kilo ohm resistor, that's R10. And there's one in here that's already bent from something else, so we'll just borrow that one. I'll double check it to make sure this is sort of the right size, because I don't think it is. Probably using that for something on a breadboard. And I think that's all the resistors. Yes, it is. Let's put the diode in there too at the same time. This is just a WAN4007 diode. Apparently this one's smaller. Bent this one a little too big, and it didn't really want to bend back. There we go. There, it's in there now. Let's get these all soldered up. After cleaning up my mess here a little bit. My tip's kind of dirty. There we go. The diode definitely could have been seated a little better. We'll call that good enough. Okay. Let's see what to do next. This button's fairly flat, but I'm actually not going to include that because it's not really necessary for this board. Let's do the 60 megahertz clock. Let me see if I can find that. That's fairly flat. It goes right here. And it's not polarized, so it can go in however. And then we can do dip sockets for some stuff next. That will be pretty easy. So for this next 485 DMX transceiver, that's the chip that's able to actually connect to the DMX network. And there's a microcontroller on here. Is Atmega 328 PPU. Those are both in a dip format. So let me find some dip sockets for those. Here's one for the 8-pin chip. These I like to try to kind of hold in, and then I'll do like 2 diagonal pins, like that one. And that one, and that I'll hold it in quite well so we can solder the rest of them. Okay, let me go get one of the bigger ones. I don't think I have any of those in this box here. No, they're somewhere else. Let me go grab one of those. Be back in 5 seconds. Going down line and soldering a whole bunch of little pins like this is really fun. Don't know why. It should be harder, but it's just fun. And there's those, they're all soldered up. Could probably do some of the, like this transistor here and some of the capacitors. They're fairly small. We're starting to get into like medium height stuff. There's some ceramic capacitors. Let's start with this transistor right here. Q1, that goes right there. First off, let me get this in focus so you can kind of see something. Let me get these capacitors next. These right here. These are C1 and C2, and this here is C3, it looks like. Yes. Let's do this dip switch here next. For anyone who doesn't know how DMX works, basically you have 512 addresses that you can pick from, and then each address can hold a number between 0 and 255. And you generally set the address by using like a dip switch like this, and I'll use binary on it. So like you have like a single light that you want to dim. You could put it at switch or like at address 1, and then you could have like an RGB light that has 3 channels, and that could be like address 2, 3, and 4 for the three different colors. and you can set it up however you want, basically. Let's do this ICSP header here, which again, I don't have any pin headers in this box. I didn't go through this, make sure this had everything I needed. I just had this box full of most of the parts I need for this board from last time I did this, and I forgot I had them all in here and I needed to build another one. I was like, oh hey, here's this box full of stuff. Oh, that pen's really bent somehow. No, tried to cut that 3. Wow. Why do these want to break like one after? Never had that problem before. Must be like an extra hard plastic or something. I think I got these somewhere different. That took off across the room. I could have just cut one off of these, but a single one by itself isn't useful, so I figured it's rarely used, so I figured I'd just keep these as 4 pins, because I'll use them sometime, even though they cost like probably less than a penny each. These can be tricky to get straight, so just have to kind of do your best for tacking one pin, and then you can adjust it as you need to. Fell out. This header here is what's used to program the microcontroller. It's called an ICSP header, which stands for In-Circuit Serial Programmer, and it's a common way of programming Atmel chips. Which this is an Atmel chip, which if you're not familiar with Atmel chips, but you are familiar with Arduinos, this is actually the exact same chip that's used on the Arduino Uno. So that makes it like super easy to use. Let's do these two LEDs here. And I think one of these is green and one's red or something. Forget how I have these. I have them labeled as one red and one blue, but I don't think I even remember any blue ones. I think the status was... Or did I have green and yellow? I bet I used green and yellow. I'm gonna make the status green and the DMX yellow. Or was it the other way? You know what? I'm gonna go check one of my other boards, so they're all the same. Hold on, I'm gonna be back in like a minute. Okay, so I just looked at a picture of one of these boards I've made before. I haven't made a whole lot of these yet, so don't have it entirely memorized yet. So the status LED is red, and I have a green for the DMX LED. Almost put that one in backwards. Okay, those are. Let's do like this relay next, and this power supply module, and these. How about we start with these? They're RJ45 jacks. Just snap in like that, and then get soldered from the other side. And let me grab a relay. And here's a power supply. These are nice little power supply modules. They're like super easy to use. They're like, I think I got these for like $2.50 each, maybe from directly from China. If you buy them from somewhere in the US, they're like $5. And it basically takes just 100 to 240 volts AC input. And then these ones are 5 volts at 0.2 amps, so they're all very low current. And you can get other voltages too, but they're just super easy for like stuff like this that doesn't need a whole lot of power, because the power is just for all the control circuitry in it. If you just want like a super easy way to put a power supply like integrated into your board, but you don't want to like fully design a power supply from scratch. And now I guess the only thing left is these screw terminals along here. I have quite a few of those. This is when you learn that soldering was literally designed for humans who have 3 hands. There's just no good way to hold this. Sometimes there's just no good way to hold something, and you have to just do your best. There, that's on there good enough that I can let go of it now. Okay, so all the components are on. Now, the reason that this has like bare traces on it like this is because those traces can carry a fairly high current, more than I would trust just the circuit board, the copper in the circuit board itself to carry. So what I like to do is basically just fill these up with solder, and then I'll carry a whole lot more current. And then I put liquid electrical tape over it, which is kind of like a liquid rubber that you like paint on, and then it dries hard. Melted power supply module a little there. That's fine. Don't know if there's a good way to do this one without melting something since it's on the top. Okay. I guess the last thing this needs is for these components to be put in here, and then we'll start on the other board. I may come up and clean this up then with some rubbing alcohol to get rid of all the flux residue then, and then we can put the that liquid electrical tape on here. But I'll do the other board that I have before that. There we go, that board's finished. Or finished for now. So next we'll do this little board here, which is super quick because it only has a couple components on. It's a very small board. So again, we'll start with these resistors here, which I believe are both 680 ohms. Here's the bill of materials for this board. Yep, they're both 680. And for these, I think I have a green LED for power on and then red for pump on. I'm pretty sure that's what it is, so we're just going to go with that. I don't know why, but these resistors are like insanely bright. They're just like standard 5mm LED resistors, but I don't know if they're like a different chemistry than normal ones or what, but they're like if you use the same resistor, like a 220 ohm resistor for 5 volts, or you know, the same resistor you'd normally use with any other LED, and you use it with one of these, they're like really bright. But I measured the current and they're still well under, it's still like well under the 20 milliamps that they're rated for. Like if you use this is a 680 ohm resistor for 12 volts. So I guess they're just like way more efficient somehow, I don't know. And I guess we'll go with this relay next. This one's a 12 volt relay. And I guess that's it for that board too. So both boards are finished. I guess what we'll do next is we can try cleaning these off, cleaning the flux off of these. I still haven't found a good way to clean flux off boards like this. So I'm just gonna do my best with rubbing alcohol and a toothbrush, and sometimes I kind of like soak them in a little bit. So we'll give it a try and see what happens. Let me clean up a little bit of stuff here first. Okay, so I got a little container to put rubbing alcohol in, which, if you're wondering why there's a piece of tape in it, I think I like melted a hole in the bottom of it and didn't feel like getting a new container, so I just put a piece of tape over it. And there's some rubbing alcohol, and there's an old toothbrush. And I forgot a rag too. So let's start with the little one because this will be a lot easier. It worked pretty well actually. Still a little bit of residue on here. Cleaning off the flux that's like stuck on around the solder joints is the easy part. The hard part is then getting all of that flux residue actually off the board. Because it tends to just kind of stay in the liquid there, and then it dries, and then you just get flux residue right back on your board. There we go. That looks like a success to me. Probably can't see too well, but it's nice and clean. So here's the other board. It's a lot bigger. So this one's going to be a little bit trickier. can see like there. I don't know if you can kind of see that on camera, but it almost made it worse because it just like smears it all over the place. So what you almost have to do is like wash the whole thing in like running alcohol, but that uses a lot of alcohol. I think if I just took this and dumped it over the board, that would probably work, but it would also make a mess everywhere and use a lot of alcohol if you're doing multiple boards. Getting better, but there's still someone there. tell you what I'm gonna do. I'm gonna dump this alcohol out, and I'm gonna get a little bit of new alcohol, and I'll do just like a last rinse with all of that because it's looking pretty good. So I'm gonna go dump this out. I will be right back. Alright, I'm back. Got this all cleaned out, so I'll put a little bit of fresh alcohol in here. And first I'll make sure I clean out this brush good, because there's probably a bunch of flux residue in the brush. Then I'm going to clean a little bit around the edges of the board here where some flux got on it in the back. And here where this spare trace that we soldered over is here. It's looking pretty clean. So I think that'll be good to go once it dries. Now, what I'm gonna do is I'll let this dry for a couple seconds, and then I will put the liquid electrical tape on here. And usually I have to put a couple coats on, but So I'll just put the first coat on. And then I know the stream title says that I'm also going to be doing a soldering kit, which is for Christmas, like a little light up Christmas tree thing. But I think this stream's long enough by itself, so I think I'm gonna not do that today. And then I have another project that I'll do within probably next week or so. That will probably take a little bit less time than this, and then we'll do that kit along with that. Or maybe that could even be its own stream. We'll just see what happens. So, yeah, let me grab this. Here's the liquid electrical tape. And it's just kind of a thick, and of course this is out of focus again. It's kind of a thick black liquid you paint on. And I guess I can do both sides. I'll have to do this side first and then the other side, because this I can sit like this and I won't touch it. Need to get like a little stick or something so I can get back in there. No, I have something around somewhere. Here, got a bamboo skewer, that'll work. Just need something I can spread it back in here with. And of course I got that all over the side of the power supply. And then I'm gonna clean this stick off, and I put some labels back here when I designed this that are way too close to this here, so I have to try to, I don't know if you can see that or not, well, not if it's that out of focus, you can't. Lighting's kind of bad in here, but like right here. So I gotta try to get this out of here. So we can read the labels. And if there's like a little bit of a thin coating left, then once I get as much as I can off now, that's fine, because that'll come off really easy once it's dry. Okay, that looks good. So then I'll just do the ones on the back quick. Okay, so I think both boards are basically entirely finished now. This one's all good to go. This one doesn't have any high voltage stuff on it that I'm going to cover. And then this one it might need another coat of liquid electrical tape. I'm not sure. We'll see what it looks like after this one's dry. And then it needs flashed through this ICSP header here. And that's about it. These are pretty much done. So yeah, I think I'm gonna wait for that Christmas tree kit, and I'll end the stream here. So thank you to everyone who's watching. I hope you enjoyed this stream. If you did enjoy it and you'd like to see more streams like this, or maybe even some more interesting ones in the future where I'm not just soldering, of course follow me, and I will see you next time. Bye.